In this video, we will talk about famous algebraic identities. In previous videos, we introduced the concept of limits and finding the limit numerically and graphically. So before to start with finding the limits algebraically, it is a good idea to make a quick revision about what is perfect square trinomial and to see some examples, difference of squares, Pythagorean identity, and finally multiplication by the conjugate. And we will use it a lot while finding the limits. Okay, so let's start with first we start with perfect square trinomial. So when we have a plus b square, both of them square, is equal to a square plus 2ab plus b square. So this comes from this comes from when you have a plus b square. This is equal to, okay, so a plus b square, this is equal to, you can write it in this way, a plus b, okay, multiplied by a plus b. So you will multiply a by a and a by b. So if you multiply them, we will get a square. A multiplied by a is a square plus again a multiplied by b is a b. Then b multiplied by a and b multiplied by b plus b a plus b square. Now this is equal to a square. We don't touch it, okay? Then ab and ba, they are the same, right? So we take 2 multiplied by a b. Why? Because if I tell you 2 multiplied by 1, it is equal to 2, right? If I tell you now 1 multiplied by 2, you see we changed the order. So for the multiplication, if you change the order of numbers, nothing will change. So you get 2 again. Okay, so this is the same. So instead of writing them 2 times, we multiply it by 2 plus b square. Okay, so you see we got the same equation, a square 2ab and b square b square. Okay, so let's see one example. Okay, so x plus 3 square is equal, so we said we take the square of first one, so we take x square plus 2 multiplied by ab. A is x here and b is 3 plus 3 b square, b is 3, right? So we take 3 square, so x square we don't touch it. 2 multiplied by x, 2x, and 2x multiplied by 3 is 6x, okay? Plus 3 to the power 2 is 9, okay? Now, what if instead of plus you have minus here? So the only thing we think will change, it is the sign which is here. So we will see that. Again, x minus 3 square, so we take x square, okay? So a square is x square, we take x square here, okay? So then we take 2 minus, okay, we take minus 2 multiplied by x, 3 plus 3 square. So this is equal to x square minus 6x plus 9, okay? Now, difference of square method, when you have a square minus b square, okay? So this is equal to, you take a plus b multiplied by a minus b. So let's see this example, x square minus 3 square, this is equal to x minus 3, x plus 3, okay? Let's see another example for the same difference of square method. So x square minus 1. So if you have this this type of equation, even if 1 does not have a square, it is automatically, you can say it is square. Okay, so that's why we apply the same formula for this. We say x minus 1 multiplied by x plus 1. Okay, finally, Pythagorean identity: sine squared theta plus cosine squared theta is equal to 1. So in the coming videos, we'll talk about that, why this happens when we say sine squared theta plus cosine squared theta is equal to 1. We will see that, but not in this video. Okay, so because we only talk about famous algebraic identities, and then coming videos we'll talk about this in detail. Okay, so you only need to memorize it like that, and we will see that why this happens. We get 1 here in the coming videos. Okay, now finally, multiplication by the conjugate. So here we have the terms. Okay, and here the conjugate, here is the multiplicand. Okay, so what is the conjugate of x minus a? So something is important. Always, if I tell you what is the conjugate of this term, you will only change the sign between this term and this term. You will only change the sign here, and the sign here. Okay, so let's do it for first one. So the conjugate of x minus a is x plus a. Okay, if I tell you now the multiplicand, what is it? It is when we say x minus a multiplied by x plus a. So this shape remind you for what? We just saw that here. We saw the difference of square method. It is a square minus b square is equal to a plus b multiplied by a minus b. You see? So here it is the same. X minus a, x plus a. It is the same, right? So you can say directly it is x squared minus a squared. Okay? Then for this one, here you have plus, you change just the sign. You change it to minus, and the multiplication, it is x squared minus a squared. Then the square root of x, so you just, then the square root of x plus a, the conjugate is the square root of x minus a. We just change the sign. Okay, the multiplication, so it is like that, the square root of x minus a multiplied by the square root of x plus a, right? So this is equal to, we take the square of x square minus a square, right? And we know that the square root, when we have the square of the square root, so this will disappear, we'll cancel this, and we'll have only x minus a square. That's why you get x minus a square. The same here, the square root of x minus b, so this minus a, this will be changed to plus. Okay, and so when we have the square root of x minus b minus a multiplied by the square root of x minus b plus a, so we follow the difference of square, so this is equal to, we take the square of x minus b square, okay, minus a square. So these two will cancel the square root and we'll get this one. Okay, so this is the idea in general. Thank you for watching, and see you in the next video.